All right, so this is going to be a video showing 18B. This was another question that a lot of you had. You can see I've already created the slope field for 18A. Interestingly, I left off a couple points, on the x-axis. At the end of the video, I'm going to talk about what we could have done there, what that really means. You should be able to think about that. Anyway, so 18B asks us to sketch the solution curve that passes through the point 0, 1. So I'm going to go ahead and get that point on there. And now I have to think about, recall that these yellow lines are really little tangent lines. And so I'm going to start to follow those little tangent lines. And in this case, they're going to go straight out. The problem is, as soon as I go along one of those little tangent lines, in theory, there's a new little yellow tangent line that I should be following. And a slope field, we're not going to have every single tangent line shown. So I really have to think about, for instance, right here, what's that little tangent line going to look like? And if you look, you can kind of look at the slopes and what's happening to the slope in other places. So as x goes from, for instance, right here, and it moves over to the right, we can see the slope becomes bigger. Right? From here over to the right, the slope becomes bigger. And if we go up to the original function, the differential equation, we can see that as x becomes bigger and y stayed the same, like originally it was 0 over 1, right? But as x becomes bigger, like 0.1 over 1, we're going to have a slightly larger slope. And so that makes sense that it's now going to start to slope upwards a little bit. And similarly, if we come over here, we're going to see that really the slope would be slightly negative there. Now, I get why this one is kind of tough because, in my head, I realize hey, am I ever going to hit these slopes here? Does it get over to that? And I have some experience with this, and that's where I have some benefit. I kind of realize that if you think about it, those slopes would always get us to another one of those slopes, right? Like that slope of 1 gets us to a slope of 1, gets us to a slope of 1, gets us to a slope of 1, gets us to a slope of 1. So really this green line almost looks to me like an asymptote. The other way that I could think about it, if this blue curve that we're trying to make is really challenging, then what if we didn't graph the blue one? Keep in mind the slope field is showing us what all of the solutions might look like, all the generic solutions. The only thing we don't know, if we're kind of going back, is kind of what that plus c is, right? Because if we anti-differentiate to get y equals, we're going to have some plus c, which is a horizontal shift. So what if instead of graphing that blue one that we're trying to graph right here, what if I just graphed one that was slightly up from that? And if I did that, I can see the job kind of becomes easier, because I have more slopes to follow, and I can kind of see what's going on there. And so I kind of get this bowl shape, and you can kind of start to see it's following again that kind of asymptote I was talking about. So these are oblique asymptotes. So again, those are kind of oblique asymptotes right there. So that purple one really starts to follow those. And so I think the blue one's going to have similar shape. It just might be a little bit more accentuated. And we're going to get something that looks kind of, like a more exaggerated bowl. Sorry, writing on a computer screen's tough for me. So we're going to get something looking like that. So again, if you ever find it tough to kind of flush out what's happening as you move over to the sides, you can think about what's happening to the slopes as they move to the side, kind of look at some of the other slopes in there. The other thing you can always do is think about what's happening to the numerical value of the slope. Or you could always just graph a different one that maybe is easier for you to see, to get an idea of what the shape's going to look like. And that can help guide you as you start to graph the shape of the one that you're interested in. These are all strategies we can use. Now, interestingly, you can kind of see these bowl shapes. If I came down below and I graphed one down here as well, similarly, I'm going to get a bowl shape. And interestingly, if I came over to the right-hand section over in here and I were to graph one, you can see I'm going to kind of get a bowl shape here also. And that really starts to wonder then that original question of like, what about the slopes on the x-axis? What do those look like? So I want you to think about the differential equation. If we were to put in a point that's on the x-axis, like 3, 0, we would really end up getting 3 over 0, which is undefined. And so when we get an undefined slope, either A, we don't have a slope, and so there should be no line there, or B, we had a vertical slope. And I think you can kind of start to see that in this case, those vertical slopes make a lot of sense. Because think about that bowl that I was just graphing on the right-hand side there. It gets vertical just for a second, and then it kind of curves back around. And that's really interesting. So we're kind of getting the same shape. These are all examples of hyperbolas. So kind of like, yeah, it's in the same family as circles and ellipses. They're just a different type of conic section. So those are all conic sections. But anyway, hope this helps with kind of graphing a particular solution. Again, keep in mind, just think about what's happening and look at the slopes around the point you're graphing. You can think about how the slope's changing, or you can kind of graph one somewhere else to get an idea of the shape.